question number 1. They're asking, right, to determine if this relation is a function. And if it's a function, specify the domain and range. Savannah, Lucero, let me see. Not a function. Excellent. Very good, guys. Very good, right? We said that in order for a relation to be a function, for each of these input values, you must have exactly one output value, right? Not two output values, right? This is not good. These forks coming out of one input value are not good for function, right? This is not a function, right? It's not a function. Excellent. So you simply click here, right? In case it is a function, then you have to go over the domain and range, right? In our worksheets, there are different forms, so practice them all, guys. Put yourself in different situations, right? Sometimes not a function, sometimes it's a function. So go over the worksheets. Great. Excellent. Number 2. Can you try number 2? No. Yeah, go ahead, guys. Yeah, practice, guys. So remember, practice makes the master. Imagine you are taking your exam, right? So something like this shows up. Savannah, very good. Let me check. Very good, Savannah. Julie also, excellent, right? Very good, guys. They're asking you if this set of ordered pairs, which is a relation, right, represents a function, right, or not. And if it's a function, it's specified domain and range. Remember, for this set of ordered pairs to be a function, I want to write here, for it to be a function, no input values must be repeated, right? Must be repeated. Yeah, we gave this hint, right? Because if one input value is repeated, you're going to end up with this situation, right? This fork. So you don't want this repetition, right? So let's check. More students posting answers. Excellent. Yeah, very good. Very good. Yeah, Jing. Yeah, we will check them out, right? The answers are always at the end, so if you want to check them out. Excellent. Very good, very good. Yeah, okay, so notice that -3, 0, 5, 6, they're all different, right? They're not repeated, right? Any of the input values. So this is good. This is good for a function. So this is a function. And not only that, these guys in yellow determine the domain of the function, right? So look, -3, 0, 5, and 6. And the range are these other guys, 7, 5, -3, -1, 7, 5, -3, -1, right? So good. This is it, right? Excellent. Very good. Next, same question, right? Is this a function? So check that out and let me know. Number 3. Very good. Savannah, excellent, right? Not a function, right? Not a function. Very good, right? Because if you look at this condition, right? For it to be a function, the input values cannot be repeated, right? You cannot have forks, right? You cannot have two output values associated to the same input value, right? So look, -11 here, good, -5 here, but here there is trouble. Look here, right? Repeat it. So, repeat it, right? This is not good for a function, right? So this is not good. Repeat it. So then you say not a function, right? Yeah, so you don't have to specify domain or range because not a function. Very good. Next, number 4. Can you try this, guys? Number 4. They are giving you a function, not a function, an equation, and they're asking you if this equation represents y as a function of x. Remember, there is a way to figure that out. You are supposed to isolate y, right? And then figure that out. Isolate y. This is the hint. And the idea is if you isolate y and you end up with y being just equal to some expression on x, then yes. But if you end up with plus and minus, remember, no, right? Because that it produces this fork, right? Yeah. Savannah. Very good, very good. It is a function, right? Excellent, excellent. Yeah. Because if you have this situation, if you solve for y by subtracting x in both sides, this is 0, 3y equal 3 minus x, and then dividing both sides of this equation by 3, look, you end up with y equal 3 minus x over 3, right? For each x, a single y, right? Exactly one y, not two y's, right? No plus minus. So this is good. This is a function. Excellent. What about number 5? Can you try number 5 now? Does this equation represent y as a function of x? Hint, solve for x, right? Solve for y, sorry. Solve for y. And see what happens, right? Remember, we don't want this situation that says y equal plus minus something, right? Because that produces the 4, right? Lucero. Very good, very good. Yeah, very good, Lucero. Y is not a function of x, right? Very good, very good. Because if you solve this for y, notice what happens. Y squared, after canceling these two, right? Y squared equal 25 minus x squared. But now, when you take square roots in both sides, since this index is even, right? This is the whole reason why we're gonna put here a plus minus. If this index is even, you have to put plus minus here, right? Even. So this takes care of this, but you pay a price there. You end up with this plus and minus square root of 25 minus x squared, right? In general, for each x, two values of y, right? One positive, one negative, right? Right? You can see plus minus. So this means that this is not a function, right? This, I gave you this hint, right, guys? If instead they say x to the 4 plus y to the 4, also same idea, right? It's not going to be a function. If this is x to the 3rd, x to the 5th, then yes, because depends on this being even or odd, right? I gave you exercises on the worksheet, so complement your preparation with those exercises too, guys, okay? The reason why this is not a function is because the exponent associated to this y is even, right? If it were odd, then yes, a function, but it's not odd, it's even. So, right? Great. Yeah, check that out. Now, decide whether the relation defines a function. So, can you answer this one, guys? Number 6. Is this a function? Is this graph the graph of a function? Let's see. Yeah, remember, hint, use the vertical line test. Hint, use the vertical line test, right? Remember, the vertical line test is used to determine if a graph is the graph of a function, right? Lucero. Very good. Excellent, Lucero. Yes, very good. Excellent. Look, if you draw vertical lines, notice that these vertical lines will meet your parabola just once, right? Once, not twice, once. No matter what vertical line you draw, they meet the parabola once. So this means that yes, it is a function, right? It is a function. So be careful there, guys. So this one, right? Number 7, is this a function? Can you do this now? Yeah, practice, guys. You don't have to be right all the time, but it's important that you practice so this becomes more and more familiar to you. Yeah, so, Julie, yeah, you made my day. Jing, and Julie, right? Very good, very good. Yeah, we are trying to find out this is a function, so we should use the vertical line test. If you draw vertical lines here, points of intersection is 1, but here, look, 2, 3. So in general, you get more than 1 point of intersection. So this one, no, right? No, not a function. What about this table? Is this a function, this table? Anyone? And tell me if this is a function or not. Yeah, very good, very good, very good. Lucero, very good, very good. Savannah, Julie, very good, guys. Yeah, very good, very good. Yeah, right. So this is the thing, right? If you kind of not sure that you want to do this nicely, right, just use sets, Jim and Bruce, right? This is the first set, right? And this is supposed to be associated with these numbers, right? This number 76, 83, 76, 96, right? Look, Bob, 76 there. Susan, 83. Susan, 83. Good. Jim, 76. Jim, 76. Right? And remember, when you deal with sets, you're not supposed to write the elements twice. So this 76 is already there. But no problem, because Jim is associated with this guy, right? 76. And Bruce, 96. Look, you don't see the fork here, right? You see, however, that an output value is shared, but that's okay, right? You can share output values, but what you cannot share are input values, right? Remember, think of this being time, right? At a given time, you cannot be at two different places at a given time, right? So that's the idea. So this is okay. So this, yes, it's a function. Yes, is a function. All right, so great. Excellent. So moving on. Now, this computational question. This is your function. Evaluate this function at -1. Can you do this? Yeah, try. Yeah, and the idea again is that you should look at X being as a placeholder, or just a placeholder. Very good, very good. Lucero, number 9. Very good, Lucero, very good, excellent. Yeah, great. The idea is to replace or substitute X with this number -1. Use parentheses, especially if you are substituting negative numbers, it will matter, okay? Now, if you want to do it in your mind, this is 1 minus 3, 1 minus 3 minus 2, minus 2 minus 7, minus 9, right? But if the numbers are not friendly, this time it was -1, but what if this is -13 or something that is not friendly? Guys, play safe, use your calculator, right? You're entitled to use a scientific calculator, so use it, right? This, use parentheses when you type in the input value, especially if it is negative, it will matter. So this times this. Notice how I'm using parentheses to avoid writing multiplication sign. And look, -9, right? Very good. Great, excellent. This was this guy. Try now number 10, another computational problem. But this time they want you to compute f of -x, right? As a hint, I will tell you that this x is just a placeholder. So sometimes it's a good idea to write the function, leaving a blank space within parentheses, because this is what this function is telling you to do, right? Square the input, whatever it is, then multiply by 3, subtract, and then subtract 1 from the result. the input value is negative x, right? So just put it there. So basically simplify this, right? Simplify that. And what do you get? Let me know. Go ahead. Number 10. Practice, guys. Something similar will come out on your exam. So make sure you are good with this master. See? Yeah, very tricky to deal with variables, right? Instead of dealing with numbers, but it's doable, right? Minus or minus plus, right? Yeah. Let me see. Lucero, very good. Excellent. Yeah, great. Yeah, great. So let's do it carefully, right? Look, this is telling you 3 times negative x squared. When you square this invisible one, there is an invisible one there, right? Negative 1 squared is 1, positive 1. So this will be just x squared. So this 3x squared, right? Minus 3 times minus x minus or minus plus 3 times x, this part, and then minus 1. After that, there is nothing else you can do to simplify this, right? This is not, this and these are not like terms, right? It's like apple, this is like orange, this is constant, so leave this alone. And believe it or not, guys, this should be your answer for number 10, right? Yeah, 3 plus x. Yeah. Number 10. Yeah, this is excellent. Very good, guys. So moving on, try to do now number 11. Okay, this one. Try to do this number 11. Excellent. Number 11 now. Let's check on the chat. Lucero. Excellent. Yeah, keep up with the good work. Excellent. Yeah, very good. You got it, right? This is a function, and they are asking you to evaluate this function at this number, -1. So basically, they're saying, right, square the input is -1, you got to square it, -8 over -1 plus 3, right? This is what you do. Substitute x for -1. -1 is square. Again, the square makes this positive, so 1 minus 8, -1 plus 3, 2, 1 minus 8 minus 7, -7 over 2, just this -7 over 2, right? That's it. Now, guys, I did it using some mental mathematics, right? In case the numbers are not friendly, let's say instead of f of -1 is f of -23. Use the calculator, right? Look, do this. I will show you. Fraction, use this form, fraction. Write on the numerator x squared minus 8, but x is -1. So within parentheses, you type -1 squared minus 8, numerator, right? Denominator, parentheses, -1 plus 3. Final answer this, right? It's a decimal, professor. I want a fraction. Click here, convert to fraction, -7 over 2, right? Don't get stuck, guys. Look, right? The decimal scientific calculator shows the result by default as a decimal, but you can turn it into a fraction, right? If needed, right? There you go. That's it. Different ways to do the same thing, right? Great. Number 12, computational, also do this with absolute values. So try this now. They want you to do f evaluated at -9, right? Basically, absolute value of -9 minus 6. Could you figure it out? Great. Number 12. Uh-huh. Savannah, very good. Lucero, also good. Excellent, guys, right? Excellent. Yeah, so this is going to be just 9. Absolute value takes care of the signs, right? Outputs just the value. 9, and this is -6. 9 minus 6, just 3, right? 3. Great, excellent. Try number 13 now. Compute f of -x. This is the function, so basically, instead of x, write -x and evaluate this, right? Simplify as much as you can this, and then identify that with your answer. Go ahead, please. Moving on. Yeah, great, great. Practice, practice, guys. Huh? Remember, when you square a negative number, you make it positive, right? Very good, Julie. Very good, Lucero. Excellent, excellent, right? Yeah, great. This is -x on the numerator, but the denominator becomes x squared, right? -1 squared is 1. So this is it. So telling us that this is the one, right? Very good for number 13. Excellent. Now, number 14 is similar. So we're going to try to, you can do it at home, similar. Let me look for different forms. This one is different. So probably you should try this. The function is a square root of 2x squared minus 3x, in case you don't see it well there. And they're asking you to compute f of 2x, right? So basically you have to do this. You write 2x instead of x, and you're gonna simplify this guy as much as possible. Go ahead and try. Remember, when you see exponents together with multiplication, exponent first, right? Exponent first. So do the exponentiation first. Let me check. Yeah. Very good, very good. Yeah, give it a shot, guys. Excellent, excellent. Very good. Very good, Jing Jing. Excellent, excellent. Lucero, Jing Jing. Great, right? This guy becomes, when you raise to the second power, 2 squared is 4, right? And this x squared is just x squared. And 3 times 2, 6, 6x here, right? But now 2 times 4, 8, right? So 8x squared minus 6x inside this radical should be the final answer of this guy, right? Excellent, excellent. This is very important, guys. Try this. F of x, I'm gonna write it big here, is this polynomial function, okay? They are asking you to compute f of x plus h. X plus h, professor. This x plus h, guys, you will get to see this again in calculus, right? When you learn about derivatives, so make sure you know how to deal with this x plus h. Yeah, so this is what you gotta do, right? Remember, x is just a placeholder, so you gotta square x plus h, multiply by -3, then distribute this, multiplying, and then subtract 2. It's gonna be a big thing, right? But try to find it, right? So figure it out. And further hint, right? This must be FOIL out, right? This x plus h squared is x plus h times x plus h, right? Yeah. Figure that out. And this is a -3, tricky, right? But do it carefully and you should be fine. I see some activity on the chat room. Let's check. Lucero. Yeah, you made my day. Excellent. Excellent, excellent, excellent. Yeah, very good, very good. Yeah, it's tedious, I agree. But again, you're gonna see this in calculus again. Important exercise. -3 here, and then you FOIL this out. X times x, x squared. Notice how I'm using parentheses to hold this result, right? This x times h, xh, h times x, again, xh, right? H times h, h squared. This is this, right? This. Plus 3 times x after you apply the distributive property, plus 3 times h, -2 there. Let's simplify this guy. -3 times x squared. Notice these two guys in the middle are like terms. 1xh plus 1xh is equal to twice xh plus h squared plus 3x plus 3h minus 2. Finally, look, multiply this -3 over -3x squared will be the first term, second term, -3 times +2 minus 6xh, -3 times h squared minus 3h squared plus 3x plus 3h minus 2, right? Believe it or not, this whole thing should be the answer, guys, because there is no way to combine like terms, right? It's like apple, orange, strawberry, I don't know, no like terms, right? So this whole thing is the answer, okay? This whole thing is the answer. Look at it term by term. Look, -3x squared minus 3x squared minus 6xh minus 6xh minus 3h squared minus 3h squared 3x 3h -2 This is it, right? Be careful, guys, when you choose your answer, okay? When you take your exam in Blackboard, you're not going to see A, B, C, D. You're going to see hollow circles there. So very tricky to choose the right answer. So take your time when you choose your right answer. All right, great. Using the horizontal line test, determine whether the function is one-to-one. Is this function one-to-one? Hint, use, remember, to determine if a function is one-to-one, you must use the horizontal line test, right? Line test. This serves to determine if a function is one-to-one, or equivalently, if a function is invertible, right? If it has an inverse function. Yeah, go ahead. Lucero, great. Now one-to-one. Very good. Jing also very good. Yeah, it's not one-to-one because when you apply the horizontal line test, notice that in general, it will meet the graph at 2 points, right? This function is 2-to-1, perhaps, right? But not 1-to-1. You may say, Professor, but if I draw my line right there on the top, on the tip, right? This is just 1 point of intersection. Yeah, but this is not what the rule says, right? The rule says that no horizontal line must meet the curve at 2 points. So we have a bunch of lines that are meeting the graph at 2 points. So this no, not 1-to-1. Very good. What about this? Is this 1-to-1? Number 18. Again, hint, apply the horizontal line test, right? Horizontal line test will tell you. Draw horizontal line. Very good, Lucero. Jing, great, right? If we draw horizontal lines here, look, it's good. 1 point of intersection. But if you draw the horizontal line here, look, 3 points of intersection. No, enough to say no, right? Great. What about this one? Is this 1-to-1? hint. Savannah. Very good, Savannah. Very good. Savannah says, yes, it's 1-to-1. Excellent, right? Look, no matter where you draw your horizontal line, 1 point of intersection, 1 point of intersection. There's 1 point of intersection. Professor, the function is broken into pieces. Doesn't matter, right? The test is the result of the test is what matters. No horizontal line meets the graph more than one. So yes, 1-to-1, invertible, right? Great. Now it's time to compute the domain of a function. What is the domain of this function? Can you try this, number 20? And remember, these domains, they come in 3 forms, right? They can be written in words, they can be written in intervals, or sometimes they can be written in what mathematicians call set builder notation, right? So you should be aware of the 3 forms. Yeah, and if you still don't see what's the domain here, hint. 1, simplify. Set denominator equal to 0, right? To investigate for which values of x this function cannot be computed, right? And these values, you have to take them away from the set of real numbers. Julie, very good, excellent, Julie. Jing also, great, very good. Savannah, excellent. Yeah, this, if you set the denominator equal to 0, this tells you that this number 1 is not good, because if for this function, right, as an input value, because 1 minus 1 will be 0, division by 0 undefined. So you say conclusion domain will be all real numbers except for 1, right? Except for 1. So you don't want this guy. Everything else is good. But this in interval notation goes as follows. Negative infinity, you never touch infinity, so you're going to use parentheses, up to 1. You are not touching 1, right? You want to avoid 1. Union 1 up to infinity, right? Which is right here, parentheses. So this is it. Excellent, guys, this guy. What about 21? Can you try this 21? Similar? Which is the value of x that is not good. And sometimes I give this hint, right? If you don't want to solve the equation, you can think of taking this as the opposite of this, right? For example, here, this was -1. We are taking away its opposite 1, right? Opposite. Yeah. Or you can set the denominator equal to 0, solve for x. That's also. Very good, Julie. Very good, Jing. Excellent, right? Excellent, guys. Yeah, great. So the number that's going to break this function is this value -3, right? So -3, because if you set x plus 3 equal to 0, that's how you get the -3, right? Yeah, in case you don't see it as the opposite. So -3 is the one that is not good. So this is 0, 1, 2, 3, -1, -2, -3. This is the number that we have to avoid at all costs, right? We take everything else. They want this as an interval. So it's going to be from negative infinity up to -3, within parentheses, union -3 up to infinity, right? Which is here. Very good, guys. Excellent. This one. Very good. That was for 21. Try 22 now. This one. Hint, this guy, when factor is this, right? So shortcut, use the opposites, right? The opposites. Remove the opposites from the number line, right? So we're talking about 7, negative, and -7, right? So these two guys are not good. Yeah, yeah, and the rest is okay for the domain, right? Everything else is good except for 7 and -7. But this time they don't want it in interval notation. They want it in set builder notation. So the one that is saying that is this, right? Yeah, very good, guys. I saw there, Jing. Excellent, excellent. Yeah. Let's do one more here. 23 is square root of 14 minus x, right? Remember, when you deal with radical functions, in particular square root functions, you gotta set the radicand. What's the radicand? Is the inside part of the radical, right? This square, the inside part of this square root function to be greater or equal than 0, right? Because this is a square root. Solve this and that will tell you the answer, right? Notice minus 14. That gives you minus x greater or equal than minus 14. Be very careful here. Remember, when you divide both sides of an inequality by a negative number, there is a price that you pay, right? And that price is this. You have to switch this guy, right? Switch, because the divisor is negative. So this will be x less than or equal than what? 14, right? So believe it or not, guys, this is the condition that defines your domain, right? Domain will be the set of all x such that this is true, right? This is true. So we're talking about this guy, right? For 23, in set builder notation. Let's finish with this. Can you figure out number 24? This is very tricky. Two forms combined, the radical form, the square root form, but also the fraction form. So you cannot let this be 0, the denominator, but also you cannot let x minus 5 be negative, right? So hint x minus 5 greater or equal than 0, and x minus 5 cannot be 0, right? Cannot be 0. Solving this, you get that x greater or equal than 5, right? And this should determine a domain in general, right? When this radical or square root function is not on the denominator, right? But because of this cannot be 0, then x cannot be 5, right? Because if x is 5, 5 minus 5 is 0. So this then becomes, as a conclusion, this conclusion, x basically greater than 5, right? Not equal. So you drop this guy, right? Because of this. So this is it. So it will be the set of all x. So domain set of all x such that x greater than 5, not greater or equal, right? Look, notice there is this other choice here. It's very tempting to go for that, but is this the one that is the right answer, right? Because this cannot be 0. 24. Question 25, it says find the domain of this function, right? The domain in interval notation. How you do that? Well, remember, in order to find the domain of a function that looks like a fraction, they are called rational functions, right? One thing you can do is to factor the denominator, right? And that way we will get to see for which numbers this function is not gonna give us a meaningful real number as an output, right? So we will take them away from the real numbers for the computation of our domain. Factoring this quadratic trinomial, we look for two numbers whose multiplication is 14, whose sum is 5. After some trial and error, those numbers are 7 and 2, right? 7 and 2. Minus here, plus here, right? So the sum is 5. So this is telling me that for the domain of this function, I have to take all real numbers except for what? Except for the opposite of this, which is 2, and the opposite of this, which is -7, right? So -7 and +2 are numbers that when plugged into this function will give us this undefined situation, so they are not good for the domain, right? So the rest of the real numbers are good. So you're gonna take everything is starting at negative infinity all the way up to -7. Skip this one, right? Empty circle, hollow circle, right? Continue with -7 and go up to 2. And from 2, go all the way up to infinity, right? This should be the domain of this function, right? And if you are curious about how we got this number, opposites, right? Opposites. So this guy, the relationship between this guy and this guy, opposite, right? Opposite. Same thing here, right? These opposites will break this function as a formula. Great. Okay, guys. So therefore, the answer for 25 should be just B, right? As you can see, guys, sometimes the domain is giving us an interval, sometimes in words, sometimes in set build notation. Let's try this one now, number 26. Again, they are asking us for the domain of this rational function, right? Rational functions are functions that look like fractions, right? Of polynomials, to be precise. Great. So how can we find the domain of this? Again, the idea is to look at the denominator, right? To figure out when the denominator is 0. But if you set this denominator to be 0, you will see that if you solve for x, right? If you solve for x, you're gonna get x squared equal -4. And when you take square roots in both sides, x should be the square root of -4 plus minus. But this one is not a real number. Later we will deal with this situation. It's a complex number, right? It is not a real number. So this tells you that this guy, when working with real numbers, will never be 0, right? Will never be 0. It's not a real number, so no solution, right? So no solution means this guy will never be 0, right? This will never be 0. This is never 0. Is never 0. So if it is never 0, it will never give us a problem. So this function should be okay for evaluations when you consider x to be a real number, right? Any real number will produce a meaningful output here. So domain, all real numbers. Another way to look at this, in case you don't like this approach of solving this equation, is this. Notice x squared, no matter what x is greater or equal than 0, right? Always. And if you add 4 to both sides of this inequality, you get to know that x squared plus 4 will be greater or equal than 4, which is greater than 0. So this will never be 0. It will be at least 4, right? So this is another way to look at this problem, right? This will never be 0. Never 0. All right, different approaches, but the conclusion should be that then the domain, all real numbers, right? Because there's no way to break this function, right? Computationally speaking. Okay, great. Okay, welcome to the ones who just joined. Alice, Ali, welcome, welcome. Khan, we are going over the review. I'm going in order. I may skip some problems if I find that they are similar, but if you feel like it's important to go over them, let me know, okay? And feel free to ask me questions, guys, during the review, okay? All right, so conclusion. Write it here nicely. So nobody gets confused, no solution. Okay, great. Now they give you a graph. They're asking you for the range. How do you compute the range? Remember, you look at how high you can go output wise, how low you can go output wise, right? This strip is very important. We even saw this strip when we did our Desmos activities, right? This strip determines the range. Highest output value, lowest output value, right? So clearly the lowest output value should be this guy, which is -4, right? notice there's a solid circle, so I'm going to use brackets all the way up to the number 2, and since this point belongs to the graph, right, belongs to the graph, I should use brackets again, right? So making the answer this. You follow, guys? Any questions, feel free to ask. Number 28. Again, look at what they're asking here, the domain this time. Domain, for a domain, you have to look at how far you can go to the right, how far you can go to the left, right? It's the interval determined by the lowest input value and the largest input value, right? This. The lowest input value is -3, bracket, because solid circle here, comma, this guy 3, bracket again, solid circle. So this should be the domain, right? You follow, guys? 28. Great. Pay attention to these little circles, right? When they are solid brackets, if for some reason they are empty circles, you have to use parentheses, right? All right, another one here. They are asking now for the range. For the range, focus on the largest output value, the lowest output value. Look, this strip is important, right? This strip. So lowest output value is -4. Start there, brackets, because this point belongs to the graph, and go up to not here but here, right? The highest output value. Look, highest. It's a little bit tricky, this one, but it's just a 1, right? -4, 1, and that's it, right? Follow, guys? Very good. Great. Now we reach to this part that deals with piecewise functions. Piecewise functions. They say compute f of -4. F of -4. Notice, since -4 is less than -1, right? You can see that clearly in the number, on the number line, right? Look, 0, -1, -2, -3, -4. 4 negative is on the left of -1, right? So that's why it's less. So therefore, we gotta take this formula, the ones that is aligned with this condition, right? Input value less than -1. So we use 4 times x. But what is 4 times x when x is -4? Well, it's just 4 times -4 minus 16, right? Minus 16. All right, guys. So this is this. Okay. Another one, let's do it because this has 3 parts. They want f of 2. F of 2. Now, question for you guys. Which formula do you think we should use here? The first one, the second, or the third one? Yeah, write it on the chat or tell me. Which formula do you think we should follow? First formula, second formula, or third formula, looking at the input value 2. Aha. Very good, guys. Very good, very good. Aha, second, this is Ali, right? Excellent, Ali, second, because the second formula is the one that is showing this, x greater or equal than 2, less than or equal than 7, right? This is including 2. So because of that, is this guy, right? This includes 2. So very good, very good. A bit tricky, but it's not hard to see. So we gotta use this formula, twice x. But twice 2 is just 4, right? It's just 4. Excellent, excellent. Be careful there, guys, with those conditions, okay? Next question, another one, piecewise function. Here, which formula shall I use? The first one or the second one when I'm trying to compute g evaluated at 5? Anybody? You can write it in the chat. Yeah, notice the 2 conditions are x not equal to 6 here. And the second condition is x equal to 6. Notice, right? Excellent. Yeah, notice that 5 first, right? Excellent, excellent, Julie, excellent, Ali. Yeah, the first condition, because clearly 5 is not equal, This equal with the slash means not equal, right? Not equal to 6. Very good, very good, very good. So because of that, we're going to use this guy, right? So this formula, therefore. Well, but if you use that formula, no hard to see that this is going to be 5 squared minus 8 over 5 minus 6, right? 5 squared is 25. 25 minus 8 is going to be 25 minus 8. Yeah, this is negative 1. 25 minus 8 is a 7. 17, right? 17 over negative 1, negative 17, right? If the computation is too difficult, I explain, guys, just bring out your calculator, have it ready, because we don't know if the numbers are going to be friendly or not, right? So if you feel like you're not sure about your computation, use your calculator. 5 squared minus 8 on the numerator and 5 minus 6 on the denominator, and you will see that indeed 17 negative is the output value. Excellent, excellent. Next question. This one I will leave it for you, okay? Similar, do it at home. Let's move on. Let's try to cover different forms. This one deals with graphing this piecewise function. How you graph this piecewise function? Well, it says for x less than 1, for x less than 1, 1 is here, right? 1 is here. Less than 1 all the way to the left. 1 is here, actually. This is negative 1, right? Yeah, so let's pay attention to this input value. X minus 1. X minus 1 means a slope 1 and y-intercept equal 0, comma negative 1, right? But what is this 0, comma negative 1? It's down here, right? Down here, 0, comma negative 1. And then from there you go with the slope 1, right? Like this. But this is good for values less than 1, not for values greater or even equal than 1. So you gotta put here, erase this part, we don't need it. It's just for x less than 1. And we're gonna put here a hollow or empty circle, right? Because we're not taking a 1, right? Now, for x equal 1 or greater than 1, the function is a constant function, 1, 2, 3, 4 here, right? Constant function. So it starts at 4 there and then goes all the way to the right. That's it, right? So look for this among the choices and you will see that for 34, the choice is there is D, right? Great, excellent. Okay, next question says find the average rate of change. Remember we talked about this average rate of change for this function. And we said that that is computed by f of b minus f of a over b minus a, right? Where a and b, they are these guys. The first that appears from left to right is a. The second that appears from left to right is b. So we have to get f evaluated at 2 minus f evaluated at 1 all over 2 minus 1, right? Now, do this computation in your mind or using the calculator. F evaluated at 2 will be negative 4 times 2, negative 8. Negative 8 plus 8, 0. 0, right? 0 here. Minus f of 1. Negative 4 times 1, negative 4 plus 8, positive 4, right? Minus 4. And all divided by these 2 minus 1. This is 1. This is negative 4. Final answer minus 4, right? Excellent. Excellent, guys. So we're talking about this guy. Yeah, excellent, excellent. Moving on, another one here. Let's take a look at this. Yeah, so yeah, it will get fixed. Yeah, let's take a look at the next. It says f of x is just x squared plus 1x from 4 to 9. This will be similar to the one that we just did, right? Similar. So let's just write here similar. So use this formula, this format, and then you can do it, okay? Yeah. Or if you feel like I should do it, let me know. This one is different, so let's do it. Again, they want you to figure out the average rate of change using this function now. And remember, this is going to be equal to f of b minus f of a over b minus a, right? What is the average value of the function between these two input values? A equal 1 and b equal 5, right? So we do that. F of 5 minus f of 1, f of 1 here, over 5 minus 1, right? But what is f of 5? 5, when computed here, look, 5 times 2 is 10. 10 minus 1, 9, right? So it's the square root of 9, which is just 3, right? 3. F evaluated at 1. 1 times 2, 2. 2 minus 1, 1. A square root of 1 is just 1. So we get this. 3 minus 1 is 2. 5 minus 1 is 4. And simplifying this fraction, we're going to get 1/2, right? 1/2. That's it. Excellent. Very good, guys. So this is when they ask for average rate of change. Another one here. Yeah, and then we can just move on. I think, yeah, this one is of t now, 9t squared. Same idea, right? You got to do for your average rate of change, S evaluated at b minus S evaluated at a over b minus a, right? So S evaluated at 5 minus S evaluated at 4 over 5 minus 4. The function evaluated at 5 is 9 times 5 squared, right? So 9 times 5 squared. Let's write it down. The function evaluated at 4 will be 9 times, we replace t for the number 4 squared, and this is 5 minus 4. This time, let's compute it in our calculator, okay? So fraction, and you do 9 times 5 is squared minus 9 times 4 is squared all over 5 minus 4. Professor, that's just 1. But in case the computation is right, you got to write it like this, right? Conclusion, this is 81, okay? So 81, small computation. In the end, you may attach the units feet per second, right? All right, great. So this is this guy. This one, I want to say similar. Try to do it at home. Let's look for different topics, different forms. Use the graph of f to determine the intervals where the function is increasing and where the function is decreasing. For this, I gave you a hint, guys. It is a good idea to travel along the function from left to right and see the trend, right? Look, if you travel along the function from left to right, look at the trend. This is going down, right? This is going down. So this should be decreasing, right? But right after this, you are increasing, then again decreasing, and then increasing, right? Increasing. So there we go. So decreasing here, then increasing here for a while, then decreasing again, and then increasing, right? So which one should be then the answer? Well, notice that over here is where negative infinity is, over here where positive infinity is. So therefore, for this, you should look for this choice, right? That's increasing from -1 to 0, right? Good. But together with this other interval from 1 to infinity, right? Because this is supposed to continue here. So, and decreasing from negative infinity, notice that this continues forever out there. So from negative infinity up to -1, decreasing with bracket, because this is part of the graph, union from 0 to 1, right? 0 to 1, that's it. D. Very good. Moving on, again, another one. I will leave this for you to do similar, okay? Let's move to other forms so we at least cover different forms. This first look a little bit tricky, so let's try to do it. Increasing, decreasing. Well, again, right? Travel along the graph. If you travel along the graph over here, increasing. And then right after this corner, decreasing, right? Decreasing. So decreasing after this corner. So walking from left to right. So increasing, decreasing here, right? So it will be increasing from negative infinity, right? Negative infinity up to this point, which is -4, and then decreasing from -4 to infinity, right? Infinity. For which one is telling us that? Well, if you look through, the first one is telling us that, right? Increasing from negative infinity to 4, and from 4 to infinity, decreasing. Very good. This one is asking you to identify the relative maxima, relative minima, right? So, I see a comment in the chat. 0. Julie is asking me, isn't it to 0? Yeah, let's go back, right? You are talking about this question, right, Julie? Isn't it to 0, you said? Which question, 42 or 43? 42. Yeah, let's explain again, right? Yeah, what happened usually here is that these, when you don't see these endings, right? Mathematicians mean that this continues forever, right? This continues up to negative infinity, right? It's continues decreasing. So this will continue the graph, right? So therefore, you have to start at negative infinity, right? For increasing where? From negative infinity starting, right? Up to this point, -4, right? 4. And decreasing, where? Starting at -4, right? And let's put brackets there because it's included this point, right? Brackets. Starting at -4 and ending at infinity, because this continues decreasing without bound, right? Without lower bound. And now better is Julie. It's okay now. And that is why it's this, right? Decreasing here and increasing here, right? You follow now? Yeah, continues the graph. The graph doesn't stop there, right? On the y-axis, yeah, I see. Always, this is a confusion, right? This is when you look for the range, right? Let's say they are asking for the range, probably will be -infinity up to 0, right? But the description of a function being increasing or decreasing, right, is done by looking at here at the interval. Maybe I should highlight this. Look, they're talking about this interval first, this interval, right? For decreasing is over what interval on the x-axis, right? Over this interval, negative infinity up to -4, right? And then increasing over what interval? Is over this interval now, right? So always increasing and decreasing are related to the domain of the function, to the yeah, great, excellent, Julie. Yeah, very good, guys. Yeah, great. Clarify always, right? Don't let things go, right? If something's not clear, let me know. This one deals then with identifying the maxima and the minima, local maxima, local minima, which is the same as relative maxima, relative minima, right? And those are located, I gave you these hints, right? At the turning points, right? Where you see the mountains, where you see the valleys, right? This guy we call a max, a local max or relative max. And this guy, because of a mountain, and this guy we call a local mean or relative mean, right? Because it's like the bottom of a valley, right? Yeah, and that's it. This is the two you have to identify. Why I don't pay attention to this? Because again, guys, this continues. Believe it or not, this continues going down, this continues going up. So this doesn't have absolute maximum, absolute minimum. It's just relative maximum, relative minimum, right? So these two for 43. So this is the one that you have to pick, right? Maximum at 0,1 here, local maximum, and minimum at 2, -3, right? There you go. Very good, very good. Yeah, very good, excellent. Yes, exactly. Without the word relative, this question wouldn't have an answer because this keeps growing up, This word is important, right? They're asking for relative maxima, relative minima, right? That's why I'm saying this is a relative minimum, right? Maybe we should write it. Relative minimum, because it's related to this number 2, right? In the neighborhood of this number 2, right? Local maximum, relative minimum. And this is a relative maximum, right? It's not an absolute maximum, right? Relative max. Relative max, right? Yeah, no absolute maximum, no absolute minimum, right? It keeps going now. Very good, guys. So next, moving on. This one, I leave it for you. It's the same as before, just let's use the same colors we use here. Green for the local maximums. This will be a local maximum, right? And this will be local minimum, right? Maybe I should quickly do local max on where the mountains are. Local means where the valleys are, right? And on another important thing in this question, guys, is this. All these 3 points are turning points because the trend changes in all of them, right? This guy, and this guy are turning points. The 3 of them. Turning points. Okay, so it's important there. So therefore, the answer for 44, if you look through, it should be C, the one that is telling us that these are the local minimum, local maximum also, but they are also turning points, right? Look, this is important, turning point, right? Very good. Next, we get to this computational part. It says for the pair of functions, find the indicated sum, different product, or quotient. They're asking here for the sum. So all you do in order to find the sum of 2 functions, we said is this. Is very intuitive, right? You just add the rules, the formulas of the 2 given functions, right? So just add these guys as polynomials and you should get your addition function, right? Let's put like parentheses, right? But really in reality, you're gonna just simplify this. 2 here is a constant plus this 4, 6, right? Once you remove the parentheses, right? And we're adding, so we don't need to change any signs, right? Once you remove the parentheses, 2 plus 4, 6, right? Then minus 4x, and then minus 7x squared, right? Whatever this is, simplify it, combine like terms, and you should get your answer, right? Yeah, very good. It's this guy. What about figuring out the product of the 2 functions? If you have to figure out the product of 2 functions, you have to multiply the rules that define the 2 functions, right? Now you may say, Professor, how do you know it's product? Nothing here means product. Nothing here means product, multiplication, right? Product means multiplication. We talk about this, right? Multiplication. Okay, so if you don't see anything between the 2 functions, it means you should multiply the rules that define the 2 functions, right? But now, therefore, we have to multiply 2x plus 9 times 6x plus 1. For this, we have this so-called FOIL method. FOIL this out, 2x times 6x, 2 times 6 is 12, x times x, x squared, 2x times 1, 2x times 1 is twice x, 9 times 6x, 54x, 9 times 1, just 9. Combine these 2 like terms at the center, and therefore you should get this, right? It's the combination of these 2 like terms. You should get this. 46, therefore, should be this guy, right? Very good. Moving on. I have here division of functions now. Division, yeah. So let's do it. F divided by g of x is naturally defined as f of x over g of x, right? The division of the 2 rules that define the 2 functions. The function f of x is the square root of 5x plus 5. the function g of x is this. Be careful here, guys. I'm gonna write it within parentheses, 1 over x, right? I'm dividing this guy by this fraction. Remember, when you divide by a fraction, the rule is flip the fraction, and multiply by this quantity, right? So flipping this fraction, x up here, 1 down here, multiplying these two numbers, all I'm gonna do is this. I'm gonna write x in front, then 5x plus 5 following. Kind of the rule is the simple functions should go up front and the complicated ones you put it on the right, right? So this is it. So this is this guy, right? You follow, guys? Great. Okay. Yeah, any questions, just feel free to write it on the chat or tell me. Okay, this was multiplication of functions, right? We did one for each operation. Now let's deal with subtraction. We didn't do, so maybe we should do it. F minus g of x. What is this? Naturally, this should be f of x minus g of x. But what is this difference? Well, f of x, I'm going to write it within parentheses, is 7x minus 5. G of x is 9x minus 7. Okay, so removing parentheses here, I get 7x minus 5, right? Removing parentheses here, but somehow multiplying by this invisible one, this negative 1 times 9x will become minus 9x, and negative 1 times negative 7 plus 7, right? All right, so simplifying, 7x minus 9x is negative 2x, and negative 5 plus 7 is plus 2. They also want the domain, right? The domain of this function, but not hard to see that the domain of this function, since it's a polynomial, should be just all real numbers, right? All real numbers. Very good. So therefore, the answer for this question, 48, should be this guy, right? This is the formula for the difference of the functions. It's here, and this is the domain, all real numbers. Very good. This is another difference, but I will leave it for you to do. Maybe I should write a hint here of how you can do it. This is f evaluated at 5 minus g evaluated at 5. Okay, continue there. Similar. Let's look for different forms. This is quotient also, but since it's done with numbers, perhaps we should do it, right? F of g evaluated at negative 2. What is this? This is naturally defined as f evaluated at negative 2 divided by g evaluated at negative 2. So on the numerator, evaluate your f function, which is this, at negative 2. What's this? F at negative 2. 4 times the input value, which is negative 2 minus 7. 4 times negative 2 is negative 8, and negative 8 minus 7, if you compute it, is negative 15. This is what we're going to write on the numerator, okay? Negative 15. On the denominator, g evaluated at negative 2. Use this function now, right? What is g evaluated at negative 2? Twice negative 2 squared plus 14 times negative 2 plus 3, right? Plus 3. If it looks complicated, guys, play safe, use your calculator, right? We're going to compute this in our calculator. So what should be this? Well, it should be simply negative 2 times, use parentheses for negative input values, right? Negative 2 squared plus 14 multiplied by negative 2 and plus 3, right? Plus 3. I got negative 17, right? Negative 17. Let's write this out. Negative 17. Negative divided by negative is positive. So final answer for this should be 15 over 17, which is here, right? Very good, very good. Yeah, very good. Excellent. So this one is multiplication, but since we did multiplication already, probably we should just say that this will be equal to this, right? Finish this up. It's easy. Continue, right? Similar. All right. Next. Now we reach to this part that deals with composition of function, right? Let's do composition of functions, important topic here. What is this? F composed with G. This little circle, hollow circle, means composition, right? Composition. It's not multiplication, right? It's composition. So what does it mean, F composed with G of X? Remember, we follow this rule. We go from right to left. It's counterintuitive kind of the order, right? And first, we start with G of X. This first. Once we are done with this, we put this result as the input for the next function that appears from right to left, F, right? This is what we gotta do. But now, what is G of X? G of X is, this guy is simply this 5x minus 1. And this guy evaluated at the function G, which says multiply your input by 6. After that, add 13 to the result, should be what? 5x minus 1 instead of x here in the f function, right? Plus 13. Just work this out, simplify, and that should be it. This should be 30x minus 6, right? Plus this 13. But simplify, this is just 30x minus 6 plus 13 is plus 7, right? Plus 7. So this is it, right? This is the function, the composition of the two functions. 30x plus 7 is here. Right? Very good, guys. So yeah, here is another composition, but since we just did one, you should be okay with this, right? But since the order is different, probably we should do it just for the sake of variety. G composed with F now. What is this? Well, remember, it's go from right to left. The one that appears first is F of X, right? Get that done, and the result, put it into G. But what is the F function here? The F function here is just this guy, 4x squared plus 5x plus 6, 5x plus 6, right? This must be evaluated in the G function here, right? Here in the G function here. This goes there. All right, so the G function is saying, take your input, whatever it is, in this case is this guy, right? Multiply it by 5. Remember, x is just a placeholder for the G function, right? And then subtract 8 from the result, right? This is what you gotta do. So 5 times 4 is 20, x squared. Then we have 5 times 5, 25, x, and 5 times 6 is just 30, right? 30, minus 8. This should be 20x squared, plus 25x, 30 minus 8, 22, right? 22. And therefore, you can see that the answer is here, right? Yeah, great. Moving on. Another one here for composition. Yeah, there are a lot of them. Yeah, but this one probably we should skip, right? So G composed with F of X. I'm gonna just give a hint of how to compute this. First F of X, and then this evaluate the G, right? Yeah, great. We're gonna do this, the number 55, right? Similar here. 55 says, do this composition, G composed with F of X. Again, go from right to left. Start with F of X. Then the result of this evaluated in the function G. But what is this F of X? According to this is X minus 9 over 6, right? That must be placed wherever you see X here on the function G, right? Right there, 6X. So if you do that, then you're gonna get that this will be equal to 6 multiplied by X minus 9 over 6, okay, plus 9, right? Plus 9. But notice 6 and 6, they cancel. So I get X minus 9 plus 9. but minus 9 plus 9 is 0. So this is, believe it or not, guys, x. Sometimes I explain, right? When you do composition of functions, you get back the input value. That is when the two functions are inverse of each other, right? So it's possible. So x, right? X. Surprising result, but possible x. Very good, guys. 55. So moving on. This one is a composition of function, but now with numbers. Let's do it. F composed with G, evaluate at -6. Remember, go from right to left. Start with the first function that appears from right to left is G in this case, right? Get this done. And the result of this becomes the input of the second function that appears from right to left, F, right? We're gonna do this. But what is G evaluated at -6? Well, the G function is this guy, right? G function. So we're gonna put the, instead of x, -6 there, right? And we're gonna compute it directly in our calculator, okay? Check this out. If we're gonna do 5 times -6, and that should be a square, right? Square minus 6 times -6, and plus 1, right? Plus 1. This is the evaluation. 217, as you can see, right? 217. Not this big number, so probably you need the calculator here, 217. But now this 217 must be evaluated in the function f, which is this, right? Which is this function. So now you take this guy, 217, and put it here into this function instead of x. So as a result, we're gonna do it with the calculator. We're gonna get the following. 4 negative, so -4 times 217 plus 5. Negative 863, right? Negative 863. Negative 863. So the answer, therefore, should be this, right? Yeah, as you can see, the numbers are big, guys, so you must use perhaps the calculator, right? Otherwise, probably would be difficult to do this computation. All right, next, this one, I leave this for you to do, okay? So similar. Next one deals with the table. What if they ask you to do the composition of two functions, but they don't give you the formulas for the two functions? Instead, they give you a couple of tables. Well, not so difficult because you just go from right to left. The one that appears first is G from right to left. So we're going to start there, right? G of 5. The second one that appears from right to left is F. So once you are done with G of 5, you evaluate that into the function F. But what is this then? Looking at the table. Looking at this table, anybody could tell me what is G of 5? Looking at the G table, right? In the G table. I see. Ali, very good. Excellent. Yeah. Look, G of 5, looking at the G table, right? It's the G table, right? Now this G of 5 is 9, right? It's there, 9, right? So let's put here 9. Yeah. Now F of 9 in this table. What should be F of 9 in this table? Anybody could tell me? Looking at this table now. F of 9. Yeah, maybe I can make it this a little bit bigger. Yeah. In this table, what should be F of 9? Yeah, very good, Ali. Yeah, you made my day. It's just this guy, right? 18, right? The one that is paired up with 9, 18. So and that's it. This is it. This is how you answer this question, right? If tables appear. Very good. Now this is other form. It deals with decomposing a function, right? They say this is a function that is a composite function, right? They want you to break it down into functions such that the composition is equal to this function, right? And I gave you a very nice hint. I said, if you're looking for a function f and g such that f composed with g is this guy, the hint was take as your function G, whatever is inside, right? So let G of X be this guy inside the inside function, right? And therefore, once you do that, the outside function is completely determined. The outside function should be what? The cube function, right? The one that says cube your input, right? The cubic function. So it will be just x cubed. And that's it, right? That's it. This is the choice. So for 59, we are talking about this guy, right? F of x, x cubed, and g of x, 8x minus 2. Yeah. Very good, very good. All right, continue. Let's continue, guys. Let's talk about graphing these functions, right, using transformations. Remember when they give you 4x squared plus 3, think of this parent function, f of x equal x squared, right? And we know very well that that function, when graph shows a parabola, right? Start there, start with something that you know, start with y equal x squared. Then they say you gotta multiply this by 4. So that multiplication applies what is called a vertical stretch to the function, right? It stretches the output values by a factor of 4, right? So this is the result of stretching this vertically. Now, once you do that, plus 3 means shift this up 3 units, right? So the final graph of this will be 1, 2, 3 units up here, right? 1, 2, 3. So just shift it up. This will be y equal 4x squared plus 3, right? The red one was just y equal 4x squared, the vertical stretching, right? Yeah, so if you look through on the choices, the one that is telling us that is this one, right? It's stretched vertically and then shifted up 3 units. This is another one, similar idea here, right? But this one, you have to shift your graph 4 units to the right. This 1/3 will compress your original parabola, right? Yeah, so, and then once it's compressed, you start with this one, right? Yeah, this is parabola, y equal x squared. You compress it by a factor of 1/3, right? Like this. Compression, vertical compression. The parabola gets then wider, right? Wider like this. And then the -4 means you move these 4 units to the right. 1, 2, 3, 4. So finally it should appear here, right? So this, something like this. It's just a sketch that should allow you to identify the answer. So this should be y equal 1/3 x minus 4 squared, right? Remember the horizontal shift is always counterintuitive, right? So final answer should be this. Very good, guys. So next, this deal with reflection. Start with this parent function y equal square root of x. There is a negative sign. That negative sign means that you are supposed to take the reflection about the x-axis, this, right? +2 means move this 1, 2 to the left, right? It's counterintuitive, right? To the left, 2 units. And then finally, the +1 means that you shift this up, right? So the graph will end up here. Let's use a different color, probably orange. So 1 unit up, right? 1 unit up, so something like this, right? Y equal minus square root of x plus 2 plus 1. When you look through the choices, guys, you will find it there. Look for this point, this important, right? This point is at -2,1. This guy, right? Yeah, very good, guys. This one's similar, but you're gonna work with the cubic function, right? So it's similar. It's a chair-like function, right? So just shift it 5 units to the right, do the reflection, and then 4 units up, right? 4 units up. If you do all that, you should get your answer. So similar. Sometimes when there are two candidates, I explain, right? Use some test point, for example, x equals 0, and see where the y should be, or y equals 0, where the x should be, and that will tell you, right? That will tell you. Next, this one deals with absolute value. Probably we should do it quickly. The absolute value function is this, right? Look, V as in victory, where y equals absolute value of x. And from there, 1/2 means that you have applied what we call vertical compression, right? The output values get halved. So you're talking about this. And this is a shift to the left, 6 units and up 2, right? So 6 to the left, 2 up, right? So 1, 2, 3, 4, 6 to the left, 2 up, and maybe more right there, right? So let's use this orange color, something like this, right? Very good. Yeah, this will be the graph of this. So this is this guy. When you look through the choices, this one, right? Very important point, this guy, right? 6 to the left, 2 up, remember? Yeah. Very good, guys. So next question deals with figuring out if this is a function or not. It says a special function, right? A one-to-one function, because they are talking about inverse functions, right? Does the graph represent a function that has an inverse? Equivalently, is the graph one-to-one? The graph of a one-to-one function. One-to-one. And for this, guys, remember we have a test. It's called the horizontal line test, right? So using the horizontal line test, you can see that clearly, in general, this graph meets twice when you draw horizontal lines, right? So this clearly no. What about this? Is this an invertible function, meaning a one-to-one function? Well, if you apply the horizontal line test here, look, no matter where you draw the horizontal line, even here, you meet just the graph once, right? Once. So this one, yes. Next, they are asking you to compute the inverse functions, right? Inverse functions algebraically, right? For example, here, f of x equal to x plus 7. And I gave you 4 steps, right? Step 1 is write instead of f of x, y equal to x plus 7, right? Step 2 says switch x with y, right? Because we're talking about finding the inverse function, right? The input becomes the output becomes the input. Okay, and next, isolate this guy. Isolate this y, right? So not hard to see here that if you subtract 7 in both sides, you're gonna get x minus 7 equal twice y. And if you divide both sides by 2, then you should get y completely isolated as x minus 7 over 2, right? The last step says change this y for f inverse of x, right? This is how mathematicians represent the inverse function, right? Very good. So that's it. So for 67, yeah, it should be this, right? Very good. Let's do one more here. This one is similar, I would say. Maybe we should look for variations. This is similar. So look for variations. This one looks better. Again, follow the 4 steps. First step to get the inverse function is change f of x for a y. Second step, switch variables, right? Switch variables. Where you see x, right? Y instead, where you see y, right? X instead. Third step, the longest, isolate y, right? Isolate y. In order to isolate y, what I'm going to do is I'm going to raise both sides of this equation to the third power. Why to the third power, Professor? Because I want to get rid of this index 3 on the radical, right? So y minus 2 equal x cubed. And adding 2 to both sides will isolate completely y, right? So this will be x cubed plus 2 equal y. Last step is simply, instead of y, write f inverse, right? It's a notational step, you know, this is it, right? So you present your inverse function, right? There we go, that's for 69. Excellent. Let's do this and then we will take a break, okay? This one, they want you to find the inverse function. Sometimes the students ask me, Professor, it says here, if the function is one-to-one, find its inverse. If not, write not one-to-one, right? Sometimes students say, Professor, shouldn't we check if these functions are one-to-one? If you want to check, guys, I explained, right, in the lectures. If you want to kind of confirm that this is one-to-one, graph it. Y equal 8 over x plus 6, right? X plus 6. We're graphing, so we have to use our graphing Desmos calculator. So this one, right? Graph is y equal 8 over x plus 6. And look, you get this, right? This function will pass the horizontal line test, right? Look, no matter where you draw a horizontal line, just one point of intersection, right? So it is a one-to-one function, right? It's a one-to-one function. The other strategy is just to go ahead, right? And then find the inverse function, right? If you don't encounter any trouble, any plus minus signs around, it should be okay. So if we just follow the 4 steps, y equal 8 over x plus 6, then we switch our variables, right? Step 3 says solve for y, right? So for that, what I'm going to do is I'm going to multiply both sides of this equation by this binomial y plus 6. So y plus 6 in both sides. Multiplying, right? Here they will cancel. This will be just 8. Here we will have y multiplying x plus 6x, right? Move this to the right side or just subtract 6x on both sides, right? Equivalently, you will get y times x equal 0, a minus 6x, correct? Now, to get y by itself, not hard to see, you have to divide both sides of this equation by x, right? Whatever this quantity is, you divide both sides of the equation by a quantity. So y equal 8 minus 6x over x. Now, final step is a presentation step. F inverse of x, you change this y for f inverse of x, right? Equal 8 minus 6x over x. Look for this among the choices, and clearly is here, right? Minus 6x is here, 8 positive is here, and x in the denominator. So that's it, right? That was 470. It says find the inverse function of this f of x equal x cubed minus 2. We change f of x with y, x cubed minus 2. Then we switch our variables, right? Step 2. Step 3, solve for y. To solve for y, simply add 2 to both sides of the equation. I want y by itself, so I'm going to take cube roots. The good thing about taking cube roots, since this guy is odd, doesn't require to write here plus minus, right? You do that only when the index is even, such as the square root, 4 root, right? But this is an odd number, so doesn't require that. It simply cancels this. So y equal cube root of x plus 2. This is the answer. The last step is just a presentational step. You change this y for f inverse of x, and then you write that should be equal to cube root of x plus 2, right? That's all. So looking through the choices for 71, It's just this guy, right? Follow? Very good. Moving on. Moving on is asking me, yeah, this guy. Let's keep it there. Yeah, let's continue. Yeah, let's continue here. Number 72 says use the graph of f to draw the graph of its inverse function. This is the graph of the given function f, let's say f of x. Remember, there is a property that says that the graph of f and the graph of its inverse functions are reflections of each other about this diagonal line y equal x, right? So basically, this point will appear here somewhere, right? You draw a perpendicular, you go kind of the same distance, or same can be gotten by switching the coordinate. This is 2, 11 in the original, right? This in the other function, the inverse function should be 11,2, right? 11,2, right? So, or draw a perpendicular, go the same distance, right? You will find them. So this will be reflected this way. This part will be reflected this way. This appears there. This appears here, right? So therefore, the answer should be this, right? You follow, guys? Reflection of each other about the line y equal x. Great. Moving on. We have to talk about this modeling with functions, modeling with linear functions. First question here says, and linear functions, linear, right? Linda needs to have her car towed. Little Town Auto charges a flat fee of $50, right? Plus a variable fee of $2 per mile towed. If you represent the number of mile towed with X, you will have variable cost here, fixed cost here. The sum should give you your cost function, right? Follow, guys? So this is the cost function. That can be written, of course, also in this form, right? The order of the items do not change the sum. So this is the cost function. Now they say find the cost of having her car towed 8 miles. If you let X be equal to 8, this computation will tell you the cost associated with towing the car 8 miles, right? This is 16 plus 50. And 16 plus 50 is 66, right? 66. Yeah, be careful there with the computation. $66, right? $66 is going to be the cost associated with towing this car 8 miles. So for 73, therefore, the answer should be this, right? This is the cost function. This is the cost associated to towing 8 miles. Very good. Another question here, 74. It says the school has purchased a new computer equipment for $24,000. The graph shows that depreciation, right? Loss of value, right? Depreciation of the equipment over 5 years. This point represents the time when they purchased the computer system, right? And this other point represents the time when the computer system is completely depreciated, right? Write a linear function in slope intercept form that models the value of the equipment y x years after the purchase. Y is the value, right? It starts with 24,000. Is when you just purchase the equipment, right? But then it loses value every year. How much it loses every year? It loses this every year, 24,000 over 5 years. This quotient is going to give you what it loses per year, right? Per year. But you need to multiply that by the number of years x, right? To compute how much is losing in total. So this will be 24,000 minus this quotient. This quotient, we can compute it in our scientific calculator, right? 24,000 divided by 5 is 4,800, right? 4,800. 4,800 times x, right? This will be the linear equation. Now, they say use this model to predict the value of the equipment after 2 years. If you let x be 2 years, then this y evaluated at 2, right? the value of the equipment after 2 years it was purchased should be this, right? Times 2. And that is, let's compute it, 2,000 or 24,000, right? 3 zeros here minus 4,800, which is what it loses per year in value, right? It's called the depreciation, gives me 14,400, right? 14,400. So 14,400 should be the value after 2 years. So looking through, you can see that the answer has to be this, right? This is the function here. This is the value after 2 years, 14,400. Very good, guys. Next question deals with graphing these linear functions. We did a lot about this, right? You just look at the slope and the y-intercept, right? Y-intercept is 4. From there, 4,0, right? Y-intercept. You go -3. It's telling you go down 3 units, 1, 2, 3 from the y-intercept, right? The rise is negative, right? And the run is positive, so 1, right? Run 1. So 1 here, and then connect the 2. That should be the equation when graph, right? So that I think we're okay with, right? This is this. And it's decreasing because if you walk along the line from left to right, going down, right? Going down, this means decreasing, going down. Very good, guys. So this is it. Next question is to find the equation of the line having a slope 3, negative, and having this point or passing through this point, right? We explained that this is computed as y minus y1 equal m times x minus x1. What is x1? What is y1, Professor? These are the values, right? This is called point slope form. So it's just this, right? If you work this out, y minus 8 equal negative 3x. Minus and minus plus 4 for a moment, but times negative 3 will be negative 12, right? Negative 12. So plus 8, y equal negative 3x minus 4. Negative 3x minus 4, which is telling us that this is it, right? Very good, very good. Moving on. This is for the case when they give you 2 points and they ask you for the slope, right? And not just that, they ask you for the equation of the line, right? So compute the slope first as y2 minus y1 over x2, negative 1 minus x14, right? This is positive 5 plus 8 is 13. This is negative 5, so the slope is negative 13 over 5. Then you choose a point to work with. I'm going to choose the first one. Doesn't really matter which one you choose to work with, but this together with this point should determine the equation of your line once you follow. This is what we call point slope form, right? y1 is negative 5 here. Slope 13 over 5 times x minus x14. Do the math here, plus 5 equal 13 over 5x minus 13 times 4 is 52 over 5. Okay, now here you have to add 52 over 5, add 52 over 5, right? To isolate your y, right? No, just 5. I think I don't need a fraction really. Because it's this, right? Or you have to do minus 5, minus 5. Now, these guys should be done using the LCD if you want to do it manually, right? But I explained also you can use or help yourself using the calculator, right? How can we do that? Well, I will show you. Notice that this is negative, so this should become negative. This should be positive, right? Yeah, great. Yeah, okay, so how you compute this with a calculator? 52 over 5 minus 5. Well, just bring it out. 52 over 5 minus 5, right? You get this 5.4. You want it as a fraction, click here, 27 over 5, right? 27 over 5. So plus 27 over 5. If you don't want to use the calculator, you can get the LCD of this is 5 and multiply this by 5, top and bottom here, and then get 25 plus 52 is the subtraction is 27, right? So you will get it one way or the other. Very good, guys. This is negative. Don't forget, be careful with the slope, right? So the choice that you have to pick there should be this one, right? Minus 13 over 5 times x plus 27 over 5. Great. This one is graphing this. I did one already, so similar. Let's move on. This one deals with parallel and perpendicular lines. Okay, this one, let's write this as similar. And let's just do this because it's similar to this. For this question here, they are asking you to figure out what is the, probably we should do this because it's parallel, it's perpendicular, right? Yeah, let's do it quickly. Yeah, for parallel lines, remember you pay attention to the slope, -2 here. And since you are dealing with a parallel line, the slope stays the same, right? And now the point is 4,5. So with this slope and this point, you go ahead and follow a slope intercept form, x1, y1. And that should give you the answer, right? Y minus 5 equal -2 slope, x minus 4. Y minus 5 equal -2x. -2 times -4 is +8. Adding 5 to both sides of this equation, we get that y equal -2x plus 13, right? And that should be the equation of the parallel line, which is here. Very good, guys. So now let's do the same with a line that is perpendicular to this passing through this point, right? Again, you pay attention to the slope, but this time, since we are dealing with a perpendicular line, in order to get the slope of the perpendicular line, you have to do two things to this guy, right? You have to flip it, and then change its sign, right? When you flip, you will get 3 up here, 1 down here, 3 divided by 1 is 3. Changing the sign from positive to negative, you get the slope must be -3, right? The slope -3.2, -4, x1, y1. Using your point slope form, you get this, y minus y1 minus -4 equal slope -3, x minus 2. Y plus 4 equal -3x, -3 times -2 plus 6, right? -4, y equal -3x plus 2. That's it, right? Y equal -3x plus 2, which is here. Very good, guys. Now, these examples are similar, right? But they just deal with this graph. They are giving you the point here. The slope is 2. So you do what we did before, right? This is the point passing through. So similar. This one similar as well. It's perpendicular, right? But there's a point there. What is the point, Professor? 1,3 right there. And the slope, you gotta flip and change the sign of this, right? So similar. Yeah, we did a lot of this. Now let's focus on the, let's make sure we go over all the forms here on the questions related to modeling. So for example, here the first one says, if an object is dropped from a tower, sorry, then the velocity v in feet per second of the object after t seconds can be obtained by multiplying t by 32. So 32 gets multiplied by t and adding 10 to the result, plus 10, right? So this defines this linear function. Find the function v of t relating the velocity to the number of seconds t. This is it, right? This is the formula, the linear function. And they say use this function to find the velocity of the object at time t equal to 0.2 seconds. You have your function b that depends on the time. To emphasize that, mathematicians attach to this v within parentheses t. So this is telling us that if you substitute t with 2.2, this should tell us, right, what is going to be the velocity after 2.2 seconds. So you got to compute this in your calculator. 2.2. Let's do it together. So 32 times 2.2 plus 10. I get 80.4, right? 80.4. So 80.4 is going to be the velocity, 80.4. Now, in the end, you may attach units feet per second, right? Feet per second. So this is telling us this, right? Very good, guys. Another question here, 84. This deals with a different form. So let's go over this. It says a faucet is used to add water to a large bottle that already contains some water. After it has been filling for 3 seconds, the gauge on the bottle indicates that it contains 18 ounces. Very important, guys. We said that for these situations, you pair up input with output values, right? Here. After it has been filling for 10 seconds, again, input value 10 seconds, the gauge indicates that the bottle contains now 53 ounces. So this is the output value that corresponds to this input value, right, of water. Let f of x be the amount of water in the bottle x seconds after the faucet was turned on. Write a linear function that models the amount of water in the bottle in terms of x. We explained in our lectures that basically we have two pieces of data here. 3 input value goes with output value 18. So x1, y1, right? And also we have the 10 seconds goes with this amount of water, 53 ounces, right? 53 ounces. So this should be our x2, y2. All right, so basically you have to find the equation of the line passing through these 2 points, right? Given by these 2 coordinates. All right, to do that, compute quickly the slope as the difference of y2 minus y1, so 53 minus 18 over 10 minus 3. This slope, when computed, and you should do it with a calculator probably to play safe, right? In case you cannot do this in your mind, just type this, highlight, slash, 10 minus 3, right? Or you can use this fractional form also. Same, 5, right? 5 is what I get, 5 ounces per second. So with this slope and this point, figure out the equation, right? It's not hard. Figure out the equation, right? With this point, the slope, figure out the equation. Well, it's going to be y minus y1 equal slope times x minus x1, following our point slope form, which is a form that you will use in calculus. A lot try to get used to this form, x minus x1, 3 there, right? Then just simplify, right? Simplify carefully, right? So that you don't make any mistakes. So minus 15 plus 18 plus 18, y equal 5x plus 3, right? 5x plus 3. Now remember, y is just the output value, but the output value is the same as f of x, right? F of x is the same always as y. So we can use, instead of y, write f of x, and then we get the functional notation for the answers with this, right? You follow, guys? Very good. Discover the form. So when you see 4 numbers there, most likely you have to follow this strategy, right? Pair up input with output value, right? And find the equation of the line. Going through at 2 points. This one was a bit tricky, so let me do it. 85, it says regrind ink, regrinds, use typewriter platens. These typewriter platens, you should visualize them as toners, right? cylindrical pieces, right? The variable cost per platen is $1.20. The total cost to regrind 50 platens is $500. Find the linear cost function to regrind platens. If reground platens sell for $10.20 each, how many must be reground and sold to break even? Remember, when you see this word to break even, it means we have to set the revenue function equal to the cost function, right? But first, let's find the cost function. The cost function, it can be broken down into what we call fixed cost plus variable cost, right? Variable cost. The fixed cost, I don't know what it is. The variable cost, I do know is this, right? So let's try to figure out what is this fixed cost. How, Professor? Well, you have this information. The total cost to regrind 50 platens is $500. So the total cost to regrind 50 platens is $500. So this will be the fixed cost plus the variable cost, right? But what is the variable cost to regrind 50 platens? 50 times 1.2, right? The cost of to regrind one platen, right? From there, I can find the fixed cost associated to this process, right? Think of the fixed cost as being the cost of paying the rent or the cost of paying some amount of money that does not depend on the number of items you produce, right? So from here, clearly the fixed cost, let's symbolize this with F. This would be this. This is 50 times 1.2. It's computed. 1.20 is just 60. 60. So meaning the fixed cost, subtracting 60 in each side of the equation, or from each side of the equation, better said, will be just 440, right? $440 is the fixed cost. Now to break even, right? This is the condition. Set cost function equal to revenue function, right? So the fixed cost was 440, right? So then what should be the cost function? Cost function will be 440 fixed cost plus variable cost in general, 1.20 times X, where X represents the number of items that we're going to produce, right? This is the cost function. Revenue function, they say that they're going to sell each reground platen for $10.20. $10.20. Since the revenue measures the money that you get out of selling your items, 10.20 times X, right? Now we just gotta solve this for X. Subtract 1.20X in both sides. You get here 440 equal 0 here. Here, this is just 9X, right? And therefore, dividing both sides here by 9, we get our X, right? Divide both sides by 9. X equal 440 divided by 9. 48.88. But since we are dealing with number of items, let's round this up to 49 items, right? To break even, 49, approximately equal to 49 when you round it to the nearest whole number. So 49 platens, right? Very good, very good. So that's to break even. So therefore, the answer should be this guy, right? This is the formula, which is written here, the cost function, 1.20 plus 440, and 49 platens is approximately what you need to break even, right? To break even. Platens here, very good. Very good, guys. So that is how you deal with this question. This one, 86, I think is easy, and it falls into the category of fixed costs. They give you the fixed cost and they give you the variable cost. So just follow this, right? Cost equal fixed cost plus variable cost, and it should be easy to solve. So this one's similar. Let's focus on this one now. This one falls into the category of pairing up input values with output values, right? They say that if persons taking 30-hour review course, they get a score of 620 on exam. But if they increase the number of hours of preparation to 70 hours, they will score better, right? They will score 794. So look, input 30, output 620. Input 70, output 794. So basically, you just have to find the equation of the line going through these 2 points, right? 30 goes with 620, and 70 goes with 794, right? Yes, you can do that. Yeah, continue there, similar, right? To the one that we just did up here. This one, there is one, right? Pairing up, similar to 84. Yeah, you can do that, guys. So let me move on to 88 to encounter, to make sure that we're covering at least the main forms. So this one says, Northwest molds plastic handles, which cost $0.90 per handle to mold. The fixed cost to run the molding machine is $2,213 per week. If the company sells the handles for $1.90 each, how many handles must be modeled and sold weekly to break even? This break even, guys, as soon as you see that, you have to set break even. I'm gonna write here, set cost function to be equal to revenue function, right? Means no profit. You just get your money back to break even. But this cost function can be easily computed as the fixed cost, which is 2,213, right? Plus the variable cost. They say that the variable cost is determined by this number, $0.90 per handle, right? So this times X, the number of handles we're going to produce. The revenue is determined by how much you're going to sell each item for. They say you're selling each handle for $1.90, right? So 1.90 times X is the revenue. So we're going to solve for X this. Subtract 0.90 in both sides, okay? So here you're going to get 2,213 equal, this is 0, this is just 1x. So 1 into this guy is the same, so 2,213 should be the number of handles that we have to consider to break even, right? So this guy, this here. Very good, this guy. That's it. Very good. Next, let's take a look at this problem. Again, this falls into the category, I think, of pairing up input with output. So I'm going to just do the pairing here. A vendor has learned that by pricing caramel apples at $1, sales will reach $132. No, the 132 caramels, right? But raising the price, if he raises the price to $2, well, less people will be willing to pay this for this increase, right? So the number of caramel that will be sold will decrease to this guy. So pairing, right? Look, input 1, output 132, input 2, output 80. So do that, find the equation of the line passing through these 2 points, and you should be good with this problem. So similar to this guy, right? 84 again, right? Pair up input with output. 84, great. You will find the equation of the line. Let's see, let's look for more forms. 90 here, see with this, it says normal town high school's pool record for the 100-yard freestyle was 47.8 in 1990. Assume that the record falls at a constant rate. Constant rate, very important word, is giving you the slope, right? The constant rate for the linear function. Seconds per year. What does the model predict for the record in 2010? Okay, first, let's write out a linear function for the record, right? The record will be the initial one, that is this guy, 47.8, plus a slope, which is given by 0.03, right? The constant rate of change, multiplied by the number of years that has passed after this year, right? 1990. It started all at 1990, and then now you're trying to figure out what is going to be the record in 2010. How many years between 1990 and 2010? From 1990 to 2010 years, from 2000 to 2010, 10 more years, for 20 years, right? So basically, you just have to plug that in here, the 20 years, right? Let t be equal to 20 years. And basically, this should tell you, right, how much you expect the record to fall to. Okay, so let's compute this together. 47.8 plus 0.03 times 20, 48.4, 48.4, right? 48.4. 48.4. Yeah, so then we're talking about this 90. Yeah, this is minus, sorry, because it's decreasing right at this rate. Sorry, this is minus. Yeah, whenever something doesn't make sense, guys, just change it. Remember, this decreasing the record, right? So let's recompute this. 47 has to be something less than 47.8, right? 47.8 minus 0.03 times 20 in 20 years. Per year, the record is losing this value, 0.03. So in 20 years, it will lose this whole value, subtracting from 47.8, 47.2. Now makes sense, right? It went down the record, 47.2. 47.2. This is the record, right? After 20 years. Seconds, right? Seconds, which is telling you this, right? Look, the function here with a minus, right? It's decreasing function because the record is decreasing over time, and 47.20, adding a zero here doesn't change the number, right? So 47.20 seconds is the new record after 20 years. Very good. This is good. Let's move on to this one that deals with population. It says in 1880, the population of Midwest city was 19,000. By 1920, it had grown to 20,000. If it continues to grow at the same rate, what will the population be in 1939? All right, so one thing we can do is we can compute the slope, right? The constant rate of change, because they say that this population is growing at the same rate of change, right? So the slope will be, look, take the last population, which was 20,000, right? Minus the initial population, 19,000, right? This is the difference of the outputs, y2 minus y1. Now take the difference of time. This happened, the 20,000 in 1920. This happened in 1880, right? So get the rate of change. Let's compute it. All right, so you take your calculator, guys. So you do 20,000. Let's use the fractional form here. 20,000 minus 19,000. 1, 2, 3 divided by 1920. 1920 minus 1880, right? Gives me 25, right? 25. So that's the slope, 25. Now give, they say, right, if it continues to grow at the same rate, what would be the population in 1939? 1939, right? So one thing I can say that the population will go like this, right? 25 of growth per year, right? And let's say the number of years measured with T, 25T after T years, right? Plus the initial population, right? Which was this 19,000, right? Again, this is what it gains in population each year after T years, and this is the original population. Now, let T be what? How many years have passed from 1880 to this year, 1939? Well, let's take the difference, right? So 1939 minus 1880. That gave me 59 years, right? 59 years. 59 years. So we let this be T. So population will be then 25 times 59, right? It gains 25 per year, right? So, yeah, but let me see. Difference of population, number of years. Let me just double check the rate of change, okay? It was 20,000 minus 19,000 over 1920 minus 1880. Yeah, 25. I was right. Everything good. Yeah, always check your work. Plus 19,000, right? So final answer should be 25 times 19, 59, right? The number of years that have passed, plus the original population, 19,000. 1, 2, 3. 20,475, right? As you can see, it's here. It's here. Very good, guys. Very good. 20,475. Excellent, excellent. There you go. Right, this is if you deal with population, right? Now let's take a look at this one. We're making a telephone call using, let's do this for the sake of variety. It says we're making a telephone call using a calling card. A call lasting 5 minutes costs $1.70. A call lasting 14 minutes costs $3.95. Let Y be the cost of making a call lasting X minutes using a calling card. Write a linear equation that models the cost of making a call lasting X minutes. Again, this falls into the pattern of pairing up input values with output values. Look, input value time, 5 minutes, is associated with output value cost 1.70, right? Input value, again, 14 minutes, is associated with output value 3.95. So all you gotta do, guys, is to compute the equation of the line going through the points 5, 1.70 and 14, 3.95, right? This is similar to, remember, 84, I think was the one, 84, yeah. Very good. Number 93 says you can rent time on computers at a local copy center for $7 setup charge and an additional $4 for every 5 minutes. How much time can you rent for $16? All right, let's figure out a rental function, right? The rental function goes like this. You have to pay a $7 setup price. So this should be like the fixed cost, right? Fixed rental. Plus, there is a variable rental that is $4 for every 5 minutes. So $4 for every 5 minutes, right? This is the slope, right? And that must be multiplied by T, the number of minutes, right? That's how you compute the amount of money you pay for the rent, right? So 7 plus what? What is 4 divided by 5? Let's find out. 4 divided by 5 is 0.8, 0.8 dollars per minute, right? $0.8 per minute multiplying by the number of minutes should give you the total cost associated to the minutes that you rent the computer. So this is the rental function, right? Now they say how many minutes you can get with $16. Well, let R, which measures how much you have to pay for the rental, be equal to $16, right? Solving for T, that will tell us the answer, right? How many minutes we can use the computer for $16. So let this be R16 and solve for T here, this equation. So minus 7 here, it's going to be 9 equal 0.8 T. Dividing both sides by 0.8, you're going to get here that T equal how many minutes? Let's see. 9 divided by 0.8, right? 0.8. 11.25. 11.25 minutes. 11.25 minutes is what you can get out of $16, right? So therefore, look at the equation is this, right? The rental equation is this, and 11.25 minutes is what you can get right out of that. So that's for 93. Yeah, very good, very good. Let's see, let's check more forms. This one we did, right? The same, similar to, yeah, this is similar to one that we did the regrind. Let me see, where is this? To break even, this one, right? Yeah, similar to 85. So I'm gonna write here, similar to 85. Similar to 85. This one. Maybe we should try this. 95. This a lumber yard has fixed cost of 4,700.80 per day and a variable cost of 0.52 per board foot produced. Lumber sells for 2.12 per board foot. How many board feet must be produced and sold daily to break even? Again, you see this word to break even, this phrase, right? This key phrase. So quickly you say to break even, set cost function equal to revenue function, right? This will tell you, solving this equation will tell you the amount you should consider to break even. Now the cost is the fixed cost, which is this, 4,700 plus the variable cost, but they tell you what the variable cost is $0.52 per item produced, right? So you're going to multiply this by X to get the total cost associated to the variable cost. That added with the fixed cost is the C of X, right? Revenue function is determined by this number. You're going to sell at $2.12 each item. So that multiplied by X is the revenue function. Maybe I should write here. This is the total cost function, and this is the total revenue function, right? And what is left is just to solve here for X. To solve for X, subtract 52X in both sides, 0.52X, right? This is 0. Here you will get 4700 equal 2.12 minus 0.52. That is 1.6, right? 1.6x or 1.60x, the same. Dividing both sides by 1.60x, what you're gonna get is the following. X equal 4700 divided by 1.6. Aha, 2,937. But since we are dealing with a number of units, right? Rounded up to 2,938, right? Because it is 5. So 2,938. 2,938 or feet. That's it, right? So this is the guy, 95.